I'm not standing, am I? Oh man, I am. Standing in the way. I have to stay over here. Is it up there? Good. All right. So, I'm assuming that the camera is picking me up. We can't check it, so we'll just have to work through the homework and figure this out afterwards because they're rearranging this room. Can you people on the back row see this stuff okay? Good. It's large enough? Because it might be I'll need to have to start writing larger. They're remodeling this area, so we're going to have to start working with this part of the classroom. So, and I think I will stand here. I'll just make, hopefully that'll work and I can see everybody. And if you can't see in the back, let me know so I can increase the size of what I'm writing here on the tablet. But in page 290, exercise 5.5, problem number 2, write each number in decimal form, which says I better get my calculator out because you're going to need one. If you don't have one, go get one. Because what am I going to do? I'm going to take my calculator and I'm going to punch in 3. Then I'm going to punch divide by. That's what that means. Divide by 10. And I get 3, division sign 10 equals 0.3. So that's the way you do all of those. Nothing complicated there, right? Problem 14. Even though I put them all on here, we don't have time to do them all, so I'll do one of each kind, and if you need help after class, I'll try to help you with it. Number 14 says 7 divided by 8. So I punch in my calculator 7, division sign 8, and I get 0.875. And that's the way you do all of those. Oh, number 20. We better look at number 20. Number 20, take your calculator and punch in 7, and then hit division sign, 6, hit equals, and what do you get? Do you get 1.1666 and it just keeps going? Now see, it depends on how many spaces your calculator has. Now some calculators will put, at the end, they'll put 7. Because it's rounding it off, because it only goes so many places. But can all of you see from this pattern that the 6 is repeating? So I can write this as 1.16 with a line over the 6 because that line means the 6 repeats. Because they're not asking you, see, watch what happens. 7 divided by 6 is approximately 1.16. No, 1.17. If I rounded it off. Do you follow that? That doesn't look like a 7, does it? 1.17. That's approximate. Because, and why is it approximate? Because I rounded it off. Because it's exactly 1.16 with the 6 repeating to infinity. And they want you to do the work and give it exactly. So it's just 1.16 and the line means the 6 repeats. Sometimes the answer book will just show a bunch of things. It'll just go 1.16666 and then go ... which says it keeps going. And sometimes it'll have a line over the 6. But there has to be enough there where you can see the pattern to see that it keeps going. Any questions about that? Okay. What's 22 all about? Oh, 22 is 6 1/4. So you change 6 1/4 to 25/4. And how do you do that? You take the 4 times the 6, and what's 4 times 6? 24. Then you add the 1, and that's how you get 25/4. See, if you want to see a picture of that, I'll come over here. 6 1/4. Here's 6. And then 1/4. There's the 1/4. Here's 6. Now watch. See how I can take the 6 and put all of them into 4s? Take all these whole circles and make a 1/4 of a pie or a 1/4 of a pizza or whatever. Now, how many 4s do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and one more makes 25. Everybody follow how I can get 25 4s by drawing pictures? But we've got this little algorithm that you were probably taught somewhere to change a mixed number to an improper fraction. And then problem number 24 has one where it comes out to be 3 times 3 is 9, plus 2 is 11. So it's 11/3, and then you do take 11, hit the division sign, hit 3 equals, and you get this where this repeats. So you just do 3.6 with a line over the 6. Okay? What's 26? In 25 to 30, determine whether each number is terminating, and if it does, give the expansion. And 3 divided by 14 is 0.2142857. And does that keep going? Is that what your calculator said when you did 3 divided by 14? Okay, now, if you have that number, just write down that number on a piece of paper, 0.2142857. See, I don't know. Does that end there or does it keep going? It's hard. I mean, you can't tell by looking at your calculator, can you? So watch what happens. Let's take, if 3 divided by 14 equals this, then 14 times this should equal 3, shouldn't it? So take 14 times that number, and what do you get? And you get 2.9999, and then my calculator said 8. But is this the same? Does this equal 3, or is this approximately 3? It's approximately 3. So it doesn't equal 3 exactly, which means this keeps going. You follow me? It doesn't terminate. So that's how you can check with your calculator to see if it terminates or not. And no, it does not terminate. And number 28, same thing again. You get this answer, then you take this answer times 28, and you get this number here, which is not 4. I mean, it's close, but it's not 4. So this one doesn't terminate either. You follow how to use your calculator to find whether it terminates or repeats? Then you come down here to number 30, and you take 9 and divide by 250, and you get 0.036. And if you take 250 times 0.036, you get 9. So I know that one terminates. Okay? Any questions? Does that help you understand how this works? Is that working over there? To sit over there, you can see either screen or both, or watch one with your right eye and the other with your left, whatever works. Make this stuff work for you. Problem 32. In 31 to 42, rewrite each repeating decimal using a bar and as few digits as possible. And you see how they got the 3 dots to show you that it keeps going? Well, what keeps going for problem 32? 7. So I just go, okay, 32 says 0.7, and I put a line over the 7. That's all you're doing here on every one of these. Problem 36. Can you tell what repeats? 930, 930, 930. So you put a line over 930. Problem 38. Dot, dot, dot after all those 2's. So the 2 is what repeats. You follow the process? When you look at them, can you kind of see what's repeating? And usually you can. Sometimes there aren't enough numbers listed to show the repetition, but most of these I think you'll be able to see it. It looks like they've done a pretty good job of showing you what repeats. For number 40, what repeats? 5-1, 5-1, 5-1, so you put a line over 5-1. For 42, what repeats? 3-7, so you put a line over 3-7. Well, that's enough of that. Problem 44. Any questions? Got this stuff going? There's a lot of different things we're doing today, so we've got to move pretty quickly, but you say, I better write myself some notes, because when I come back and do this, we've already done 1, 2, 3 things, and we're going to do 4, 5, 6, 7, 8 things all total. So we've got 5 more mathematical skills to master, to understand, to comprehend, to learn. Wow, are we going to have a full mathematical day? It's going to be so much fun. Some of you are going to have a headache when it's all over. And when you do, just step outside and look at the snow and say, math doesn't matter, God made a beautiful world. Because that snow does look beautiful out there. Number 44, write each number as a fraction. Now that sounds easy enough, but here's the process. Since the 6 repeats, I take 10 times the number and I get this right here. Everybody follow that? Since 1 digit repeats, I multiply by 10. Now, the number itself is this number here. Okay? Now, when I subtract from 10x, 1x, I get 9x. Everybody see that? When I subtract this from this, all of this stuff zeroes out. Everybody follow that? So I'm left with 6. So if 9 times x equals 6, then x would equal 6 over 9.
Dr. Bellingham, how do you know to use the 9? Where's the 9 coming from?
What's 10 x's minus 1x?
Oh, I see.
That's where I get the 9x. Good. Any other questions? This is the technique that you use for doing these. And then you reduce it down and you get 2/3. Let's do number 46. Now see, this time 2 things repeat. You see that? So since 2 things repeat, I'm going to multiply the number by 100. 2 zeros. And 100 times that number is 21.212121. Everybody see how I'm getting that? And then the number itself, I put it here, then I subtract this, and I get 99n equals, and all of this out here zeroes out, and I'm left with 21 over here. Everybody see how that works? It's a pretty slick little process, isn't it? It's a cool little algorithm. So I divide by 99, and n equals 21 over 99. And that reduces down to 7 over 33. Let's do another one. Now we've got three things repeating. So what do we use as our multiplier? 1,000. And 1,000 times this number gives us 102.102, 102, 102, 102, dot, dot, dot. And then minus one of these would give me 999 of them. And after I subtract this, I end up with 102. Everybody follow how that works? All that stuff zeroes out. So my number is 102 over 999. Is that cool? And then you just reduce that down. Oh, what happens here? What's repeating? 672, three things, so I use 1,000. Same thing again. 54. What's 54 doing? 2.4. Yeah, let's do this one. 2.4. The 8 repeats, so I use 10. The number is 2.4888. I subtract this and I get 9. Then I subtract this and I get 22.4. Everybody follow that? So now my number is 22.4 over 9. Wouldn't that be the same as 224 over 90? Does everyone see how I'm going from, because I want to get rid of that decimal point? So I take this times 10, and I take this times 10. If I follow the process, and I get 224 over 90. So I'm doing that just to get rid of the decimal point. Then I take 224 over 90 and reduce it down. Build my two little trees and end up with what? 112 over 45. So sometimes you'll have a decimal point in your answer when you follow this process. And when that's the case, you just multiply the numerator and denominator by a number to get rid of the decimal point. Okay? Questions? We got it? We're on a roll? Let's keep going. 56. Why did I use 100? Because 1,5 repeats. Subtract 1, I have 99 of them, and then I have equals 22.92. So, what's that going to become? 2292 over what? 9900. Everybody follow that? I take both of these times 100 to get rid of the decimal point. Okay? Same process all day long. Number 60. Now, 1, 2, 3, 4. Now we're up to process number 5 today. In problems 59 to 67, write each percent as a decimal. Does anyone know what 23.4% really means? Were you taught that percent means per 100? Were you taught that anywhere? So, I just make a fraction, 23.4 over 100. You follow me? Now, how do I change that to, what am I supposed to do? Write it as a decimal. How do I change that to a decimal? Now, since I'm following the same pattern, that would be 234 over 1,000. Then you divide 234 by 1,000, and what do you get? 0.234. What happens if you divide 23.4 by 100? Guess what you get? 0.234. Okay? You go, I was taught a shortcut. If I want to drop the percent sign, I'll change to blue here. If I want to drop the percent sign, I just move this over 2 places. Were you taught that? 0.234, looks like you got it. But if I show you this way to do it, you can see why that works. Because sometimes we're taught to do things mathematically without knowing why they work, and often it helps to know why something works to see what's going on. Number 62, 56.9%, whoops, back to red, percent is per 100. So I put 56.9 over 100, then just divide with your calculator and you get 0.569. 64.008% would be this over 100. Now you can change it, but if you just take 0.008 and divide by 100, you'll get this answer. So you don't have to put this step in here. I just put it in here because it's fun. And it helps you kind of practice what we were doing in the last one when you're changing things to a fraction. Kind of ties it all together. Since there's so many things we're doing, the more we can practice a particular mathematical skill or technique, the more it'll tend to stick in our minds. Number 66, same thing. Number 68. Now we're going the other direction. Here's 0.38, and they want me to write it as a percent. What percent would that be? Well, what would that be if I changed it to a fraction? That would be 38 over 100. Agreed? So how do you change 38 hundredths to a percent? 38%. Just like that. Look at number 70. 9.998 would be 9998 over 1,000. And that would end up being 999.8%. And if you follow that little rule you learned years ago, move it 2 decimal places to the right, and it's 999.8, and add a percent sign. If you want to drop the percent, you move it to the left. If you want to change it to a percent, you move it to the right. Any questions? Am I doing something that's confusing somebody? Not yet, huh? Okay. These are more of the same. Number 78. What do we got here? In problem 77 to 80, write each fraction as a percent. So 78 says 4 over 7. Change that to a decimal. How would you change it to a decimal? 4 divided by 7. And what do you get? This number here, 4 divided by 7 is 0.5714285. So if I want to change that to a percent, I move the decimal point 2 places, and it becomes 57 point. Why'd you stop at 1? What'd they tell me to do? Oh, number 78 says to 1 decimal place. So here's my 1 decimal place. Why do I leave it at 1 instead of making it a 2? Because I look at the 4, and if that's 5, that's less than 5, I leave it at 1. If it's 5 or more, I would have changed it to 2. Everybody remember your rules for rounding from earlier in the week? See how this whole chapter keeps building? So you want to keep good notes, so when you get to the end, you can look at your notes when you run through the practice test. Number 80. Now 80 doesn't say where to stop, so let's just work it out. 7 divided by 8 is 0.875. Now isn't that the same as 875 over 1,000? So what would that be if I dropped this 0 and made it over 100? It would put a decimal point right there. Everybody follow that? So that's why we get 87.5%. Questions? You got it? Are we on our way? We must be. I know I'm working hard when my nose starts messing with me. 82. What's 110% of 90? Oh, this is so, can I show you, do any of you remember studying this percent stuff with working problems where they had 3 different techniques for 3 different kinds of problems and you have to figure out which technique goes with each problem? Well, not anymore. I have one technique for all the problems. And watch what I do. Number 82 says what? What is? So I put a box with a question mark. Let's go back to red. I put a box with a question mark. What is? That's is. What is? What does it say? 110% of 90. So I have an empty box, and I'll tell you why I like empty boxes. It makes my mind think I'm trying to find what goes in the box. So I have an empty box equals, change this percent to a decimal, because you don't multiply with percents. When you were taught to do that earlier in life, they always told you change the percent to a decimal. So that becomes 1.10 of means what? Times 90. What's 1.10 times 90? Punch it in your calculator and what do you get? 99. So what goes in the red box is 99. Anybody not like that answer? Well, on the test, he'll put one there that you like, and then you can pick the one that you feel good about, and then when I grade it, I'll put a check mark by that one and say, you get to work that one over. I'm sorry, the guy who writes these tests, he just knows how to mess with you, doesn't he? He just, isn't this bothersome? We are just not naturally good mathematicians. It's an acquired skill that you have to work at. Number 84. 15, so watch what I do. See, have you seen my technique yet? I just start translating. 15 is 30% of, where'd it go? What number? Box with a question mark. See what I do? I just take whatever they give me and I write out a mathematical sentence. So I don't care what goes where. I don't have to have a different technique for different kinds of problems. I just translate. Then I say, okay, this says 15 equals 0.30 times something. So what would that mean if I put the box by itself? Wouldn't the box by itself equal 15 divided by 30? 0.30? Wouldn't it? Does everyone see that where I'm going from here to here? You see how I'm getting there? If 12, let me come over here and write one that you can see. If 12 equals 2 times something, what goes in the box? You can tell by looking, can't you? What goes in the box? 6. So watch. 12 divided by 2 equals 6. See why that process works? So once I know this process works, I can use it to rearrange any problem to get the unknown by itself. Number 86. Watch what it says. Find what? 12 1/4% of 320. If it says find, then that means I say 12 1/4% of 330 is what? Empty box again. Everybody follow that? So then 12 1/4% is 0.125. Everybody follow that? Everybody see where I get that? And then of is times, and 320 is 320. So what's 0.1225 times 320? Take your calculator, punch in 0.1225, hit times, hit 320, and what do you get? You get 39.2? Good. Then we're all on the same page. And I didn't make a mistake yet. Yeah, that's because last night, after I did these, I went back and checked my work and found my mistakes and fixed them before I came here this morning. Because we had so much to cover, I didn't have time to mess around with making mistakes today because we've got so much material to cover. Problem 88. One of the most expensive British cars is the Rolls-Royce Phantom 6. And it costs $312.94. Okay? So I've got $312.94. An armor-plated version cost $560,000. What percent more? What percent more does the armor-plated, what percent more, this one, what percent more does this one cost? More than what? This one. You follow what's going on? So, watch what I have to do here. I can't go directly to that percent. So I say, how much more does this one cost? So I take the 560,000 minus the 312,000, and I end up with 247,046. And then I say 247,046 is how much, what percent is what percent more than 312,950. So what I end up with is a question that says 247,046 equals what percent times this? Which means, do I have it over here? Which means I take 247,046 and I divide by 312,954. And what do you get for an answer? You get 0.78 what? You're not going to tell me? 9 what?
400.
400. So, why did I round it off like that? I don't know. I just did. So to change this number to a percent, I would move it 2 places, and it'd be 78.94%. Now, if you want to check it, take 78.94% of this, and you'll get this answer, and add them together, and they should add up to $560,000. Number 90. Bone. Refer to problem 89. Bone is 17 Bone is 17.5% of 150. Because 89, 150 pounds is how much the person weighs. And it says bone is 17.5%. So I take 0.175 of means times 150, and I get 26.25. So for problem 90, bone, what did they want to know for problem 90? How many pounds? Okay, so, yeah, that works. That's 150 pounds. So how many pounds? 26.25 pounds of bone. There's no. How many pounds of bone? 26.25 pounds of bone. Number 92. The highest recorded shorthand speed was 300 words per minute. 300 words per minute. For 5 minutes. So that means in 5 minutes, how many words? 300 times 5 would be a total of 1,500 words were taken in 5 minutes in shorthand. You follow that? And out of those 1,500 words, it said what? Accuracy was 99.64%. So I simply take 0.9964 times 1,500, and I get 1494.6. Round that off, it would be 1495. And there were 1,500 words to start with. So whoever did this made 5 errors out of 1,500 words of shorthand. 94. In a recent year, 41.2 million households watched the Super Bowl. So 41.2 million watched the Super Bowl. And what else does it say? This 41.2 million represents what? 47% of the households with TVs. So 41.2 equals 47.1% of this number. This equals this times this. So this would equal this divided by this. And what's the answer? 87 million people have televisions. Well, this book doesn't always use good numbers, because if there's 300 million people in America, there are more than 87 million people with televisions. If there are 300 million people in our country, probably at least 200 million of them have TVs. Probably 250 million. Who knows? Maybe all 300 million have access to one. Okay. So don't always try to think, well, that can't be the right answer, because that isn't even close to real life. Don't worry about it. Sometimes they make up problems that contradict real life just to mess with you. 96. The average annual cost of tuition, room and board at a 4-year public college is $8,800. So the average cost at 4-year college. And then look what it says next. And is about 8,800. This represents, 8,800 represents 40% of, what does it say? This represents 40% of the comparable cost at a 2-year college. See, that's just backwards, isn't it? In real life, that's just backwards information. It's always cheaper to go to a 2-year college than a 4-year college, isn't it? Generally speaking. So you go, okay, so now I have 8,800 equals 0.40 times my unknown. So my unknown would be 0.40, or 8,800 divided by 0.40, And what do you get? Punch in 8,800 and hit divide and then hit 0.4, and what do you get? Do you get $22,000? So that's the answer to the question, even though it doesn't necessarily fit real life. 98. Dorm rooms at a 4-year private college. So dorm rooms cost $3,200. At a 2-year college, and a 2-year college, now what here? The 2-year college dorm room is %, 98. At a 2-year college, they cost 90% as much. The 2-year college costs 90% as much as the 4-year college. So what's the 4-year college? 3,200. How do we translate as much as? Times. So now you have 90% is 0.90 times 3,200 equals my empty box. So that means I would take 0.9 times 3,200, and I would get this for an answer. 2880. See what's going on? Good. Questions? Problem 102. Farah paid $720 for books. Is this more, less, or the same as what? Where'd it go? As the percent estimated on the graph. As the percent on the graph. So look back at the graph. And what's the percent on the graph for books? Do you see the picture on page 291? You see books is kind of a little vanilla color. What's the number? On the graph, 6% of how much? See that? $12,000. So what's 0.06 times $12,000? 720. So what's the answer to the question? More, less, or the same? Here's 720. Here's what she spent. More, less, or the same? Is 720 more than 720? Less than 720? Or the same as 720? Thank you. It's the same. Everybody follow that? Number 104. What's number 104 say? Somebody spent $2,520 for transportation. Move it down there. $2,520 for transportation. Is that higher, lower, or the same? As what? As the graph. What's the graph say for transportation? 21%. As 21% of 12,000. What's 20.21 times 12,000 is what? 2520. Is that higher, lower, or the same? The same. Number 106. If 25 is increased to 30, no, that's 105. if 32 is decreased to 28, here's 32, and I decrease it to 28. I was at 32. Nope, up here. I was at 32, and I went back to 28. You follow me? On a number line. Where'd it go? 106? If 32 is decreased by 28, then 4 is the amount of the decrease. Everybody agree? 32 minus 28. But look what they want to know. They don't want to know the amount of decrease. They want to know the percent of decrease. So now I know I'm going to put 4 over some number. Now I have two choices. I can put the 4 over 32, or I can put the 4 over 28. One of them's right and one of them's wrong. Now here's how you determine which number to put under there. What's the percent of decrease? Where did I start? Where was my beginning point before I made the decrease? 32. So 32 is a number that you're working with. You start with 32 and went down 4. If it would have said what's the percent of increase, you would have started with 28 and went up to 32. So that means it would have been 4 over 28. You follow? You always have to go back to your problem and say, what number did I start with when I'm calculating increase or decrease? And then once I find the difference, I put that number over my starting point. And what does that come out to be? 0.125, but they want percent, so I write it as, move it over 2 places, 12.5%. Everybody follow that process? We have walked a long way into the deep woods of mathematics today, haven't we? And we're still not finished. And I know you probably have a headache, but we got to get this stuff done. 108. If you decrease 24, if I take 24 and decrease it by 16% of what? Of itself. What would itself be? 16% of 24. What's 16% of 24? 0.165 times 24. That gives me 3.96. So to decrease 24 by 3.96, I subtract the 3.96 and I end up with 20.04. Take your calculator, punch in 24, then go minus 3.96 and see what you get. Any questions? You got that one? Number 110. Felicia received a 1,750 raise. Her salary was $25,000. So, what was the percent of raise? I know the how much raise was $1,750. Now, $1,750, where did I start? With $2,500, $25,000. So that's the number that goes underneath. And when I divide that, I get 0.07, so that comes out to be 7%. So she got a 7% increase. 7% of her salary, her increase amounted to 7% of her salary. You follow the thinking for solving these problems? It shouldn't be a long, complicated process. It should be pretty straightforward. If it's not, stay after class and we'll keep talking about it until it makes sense to you. Number 112. Here are some professions and the average salary earned by males and females. You ladies aren't going to like this one, are you? How much more did males make in each profession? How much more did males make? Here's the male salary. Here's the female salary. So you subtract those two and you get 3,000. And what does it say? for problem 112? How much more did males make than females? So the 3,000 is from females up to males. So I put the 3,000 over the female salary, and that says they make 4.4% more. That's if you're a manager at Walmart. Watch this. What if you're a technical officer at Walmart? Well, the males make 73,000 and the females make 50,000. Don't make it worse than it is, Tom. And so what's that come out to be? 23,000. But, so I put 23,000 on top. What goes underneath? The female salary over 50,000. And that's a 46% difference. Now somebody's going to get bent out of shape about that one. And that's why Walmart's had to change their policy. What about CEOs? Well, surprisingly enough, it's worse for people in technical positions than CEOs, because the man makes 127,000, she makes 95, 32,000 difference. Divide 95,000 into that, and the guys make 33.68% more than the girls do when they're running the company. Now that's changing because the women have decided we're not going to let the men get away with it anymore. We're going to speak up and say something. Whereas in the past, if a woman spoke up to say something, what did the CEO say? If you don't like it, go get another job. And then finally they decided that they weren't going to get away with that anymore. Number 114. Gail learned that a new hairdresser's fees were only 80% of her present one. So the new fee is 80% of the present fee. You see where I'm looking for information to give me a mathematical sentence? The new fee, does it tell me what the new fee is? No, it says her present fee is $25. And it's 80%, so that would be 0.80. 0.80 times 25 would give me the new fee. And what's the new fee? 20. So what's the question? If her present fee is $25 a month, what would be her monthly savings? What's her monthly savings? Now see, if you put 20 down for the answer, you missed it. Because it didn't ask what's the new fee, it said how much did she save? And she was paying 25, and now she's going to pay 20, so her savings is what? $5. Everybody follow that? Good for you. Stop when you get to problem 115. Stop at number 115. And that's enough to wear you out, isn't it? This is about the busiest day you're going to have all semester long. Thankfully, it's on Friday. You have a whole weekend to spoil your weekend by doing math. I'm the only one that's going to have fun doing it. I sure had fun getting this ready. If you get stumped, bring your questions to class on Monday, and I'll help you with it. All right, you're out of here. If you have questions, stick around. I'll answer your questions.